Hey everyone, welcome. Today we're going to dive into one of the most powerful and, frankly, life-saving tools in any Linux admin's toolkit, the Logical Volume Manager, or LVM. We're going to break down how you can manage your disk space on the fly so you're always in control. Let's get right into it.
So you've been there, right? That dreaded alert pops up, an application server is screaming, a database is about to fill up, and suddenly you're scrambling for more space. Well, this is the exact problem LVM was built to solve. It turns that potential crisis into a simple, totally manageable task.
So here's our game plan for this explainer. First, we'll talk about what makes LVM so great, its flexibility. Then we'll cover the basic setup and walk through the two big operations, growing and shrinking volumes. And to wrap it all up, we'll go over some golden rules to make sure your data always stays safe.
Okay, so what exactly is LVM? The easiest way to think about it is as a clever abstraction layer. It sits right between your physical hard drives and your operating system. So instead of being locked into those rigid physical partition sizes you set up at the beginning, LVM lets you create this big, flexible pool of storage that you can change and resize whenever you want, usually without even needing to reboot.
Now, before we can get to resizing things, we've got to understand how it's all put together in the first place. So let's do a quick walkthrough of the basic building blocks of any LVM setup. Don't worry, it's actually a pretty straightforward three-step process.
So here's the flow. First, we use pvcreate. That's us telling Linux, hey, see this disk or this partition? It's now available for LVM. Second, we use vgcreate to bundle one or more of those physical volumes into one giant pool of storage called a volume group. And finally, with lvcreate, we get to carve out a chunk of that pool to create a usable logical volume. See? Simple. Physical disk to storage pool to usable volume.
And here's what's so cool. Once you've created that logical volume, Linux just sees it as a regular old hard drive. It doesn't care about all the magic underneath. So you still have to do the standard stuff, put a file system on it, like with mkfs.x4, and then mount it to a folder so you can actually use it.
All right, let's get to the main event. This is probably the most common LVM task you will ever do, extending a volume. This is your go-to move when an application needs more room to breathe. And the best part? You can do it completely live, with zero downtime.
Now, the whole process is kind of like a two-step dance. The first step is to use the lvextend command. This tells LVM to make the container, the logical volume itself, bigger. So at this point, LVM is aware the volume has more space, but the file system living inside, well, it has no idea yet. It's still stuck at the old size.
And that brings us to step 2, resize2fs. This command is what talks to the actual file system, in our case, ext4. It basically says, hey, guess what? There's all this new space available for you. Go ahead and grow to fill it up. And boom, just like that, your operating system can see and use all that new space.
But wait, why do it two-step dance when you can do it all in one move? This is the real pro tip. If you just add the R flag to your lvextend command, it tells LVM to automatically run resize2fs for you right after it extends the volume. It's faster, it's way simpler, and there's less room for error. Honestly, this is the way you should always do it.
And get this, the flexibility doesn't even stop there. What happens if your whole storage pool, your volume group, runs out of space? No big deal. You can literally install a brand new hard drive in the server, run pvcreate on it, and then use vgextend to add all of that new capacity to your existing pool. Then you're free to keep growing your logical volumes. It's amazing.
Okay, so let's flip the coin and talk about the other side, shrinking a volume. Now, while growing a volume is easy and totally safe to do live, shrinking is, well, it's a much more delicate operation. It's great for reclaiming space you don't need anymore, but it demands caution and, this is important, it requires downtime.
And this is the absolute key difference. Unlike extending, you cannot shrink a standard X4 file system while it's mounted and in use. You have to take it offline first. Seriously, trying to do this online is a guaranteed way to corrupt your data. This is the one rule you can't bend. The procedure for shrinking has to be followed in this exact order, no skipping steps. First, you unmount the volume to take it offline. Second, you run a file system check with e2fsk, just to make sure everything's healthy. Third, and this is the most critical part, you shrink the file system inside the container with resize2fs. Only after the file system is smaller do you shrink the LVM container itself with lvreduce. Then you can bring it back online and remount it. I cannot say this loudly enough. If you shrink the logical volume container before you shrink the file system, you have just used a digital chainsaw to chop off the end of your data. Anything that was living in that space is gone, forever. It is the cardinal sin of LVM. Always, always, always shrink the file system first.
Okay, I know that was a lot to take in, especially the scary parts about shrinking. So let's just boil it all down into a simple set of golden rules. Think of this as your pre-flight checklist for managing LVM safely every time.
This slide really says it all, doesn't it? Look at the difference. Extending is simple. It's online. It's one command if you use that -R flag. Reducing, on the other hand, is complex, it's offline, it's a whole multi-step procedure where the order is everything. Just remembering this one fundamental difference will save you a world of trouble.
So here they are, the big takeaways. Number 1, always shrink the file system before the logical volume. Number 2, always extend the logical volume before the file system. Or better yet, just use R and let it do it for you. Number 3, always run that file system check before you even think about shrinking. And a little bonus pro tip, if you're using the XFS file system, just know that while you can grow it online, you can't shrink it at all, so you gotta plan ahead.
And to help you put all this into practice, we've got this handy command reference table. Just think of this as your cheat sheet. When you're sitting at the command line, this is a great little visual to have to remind you of the right tool for whatever job you're doing, whether it's creating, extending, or very carefully reducing your volumes.
And there you have it. That's your crash course in resizing LVM volumes. You now have this incredible power to manage your storage dynamically. So the real question is, what are you going to do with it? Maybe you'll script something to automatically extend a volume when it gets low? The possibilities are pretty much endless.